Alright, chemistry. This is a video for the notes that are on page 52. You should be doing this kind of like in between your B day and your C day. Because B day, we did a lab with the cans and crushing them. C day, I'm going to do a lab that's based on like the information here. But I think that you can kind of suss out what's going on here. Thermochemistry is difficult as a class, but straightforward as like a single topic within our class. So I just want to quickly go over these notes. Keep in mind that on Friday, regardless of letter day, there's going to be a quiz online. I think I said this in the last video, or last class, I don't know, last video, last class, whatever. Starting from page 47, where we start talking about gases, all the way through to these notes in this equation here on page 52 and 53, right? I won't do, the quiz will not cover page 54. We'll start that right after the break. I was going to start it before the break, obviously, but snow days and such. So we adjust. It's not a big deal. But hopefully you're watching this in between your B and C day. So, quick definitions of like what is thermochemistry, how do we solve for things in thermochemistry, and what are we going to be looking at? So thermochemistry is this, oh goodness, that is, I need that one. Thermochemistry is the study of, yeah, there we go, heat and energy that is associated with like doing a chemical reaction. So we've talked about what you need to start a reaction, we've talked about what you need to finish a reaction, or what you make at the end of a reaction, but we haven't discussed how heat and energy kind of tie into that. There is pretty much always some kind of transfer of energy that we look at, that we study. When we do experiments, right, we're not looking at everything around us, we're looking at a very specific part. So the part of the universe that we're studying, that we're looking at, is referred to as the system. And the rest of the universe, anything that we're not like directly looking at, we call that the surroundings. Typically, so like in the case of the can crush, right? Our system is the can and the gas inside the can. The surroundings are literally everything else. That's pretty much going to be how we define what a system is. Ooh, excuse me. Been a long day. How we define what a system is, and how we define what the surroundings are. All right. So heat specifically is a transfer of energy. So heat is not like literal temperature. It's how we measure the transfer of energy from one space to another space, typically between the system, whatever we're looking at, and its surroundings. The way that we define heat flow and kind of where it goes, it will always be transferred from the hotter object to the colder one until they both reach the same temperature. And this has a special name. It's called thermal equilibrium. Thermal, like heat, or having to do with temperature, equilibrium being equal. So when the two objects reach the same temperature, then we would refer to that as thermal equilibrium. So if I was holding an ice cube in my hand, the ice cube would begin to melt into water, and then the water would heat up until it and my palm were the same temperature. Right? Now, if you have energy transferring, because heat is a transfer of energy, energy is conserved, so whatever heat is gained by one object, or gained by the system, gained by the surroundings, was lost by the other one. Because heat is energy, the units for energy are the joule. Yes. Yeah, it's funny. I have to laugh at it. Anyway. It's if you're abbreviating, it's just a capital J. And in order to calculate how many joules of heat get transferred from one object to another object, from the system to the surroundings, you have to know three things. Those three things are the mass of the object. You need to know, for lack of a better term, that's not how you spell identity. Identity of the object. I'm saying object, the notes say system. It means just we're referencing the same thing here. So you need to know the mass of the system, the identity of the system, and the change in temperature. Now, change in temperature is very specific. So make a little note here, even though there's no blank to fill in, right? This equation is on the reference table, right? No memorizing. It's in a section called heat calculations. There are actually 3 different calculations that you might make for heat. Depending on the situation, you're going to know which one to use, all right? Hello? There we go. This equation is on the reference table. And so Q is heat, M is mass, C is the specific heat capacity. That's something that we'll touch on in a lab we'll do right after the break. But specific heat is unique to every substance, and it's something that you would have to be given. You would have to be told that information because it's only on the reference table for like 2 or 3 substances. So if you need it, you will be given it, or it will be what you are solving for. That will be your unknown. And then delta T. This triangle is a Greek letter delta. It means change in. So delta T means change in temperature. This means something very specific. This means final temperature minus initial temperature. And it will... that's not how you spell initial. It will always mean that. So delta anything is always going to be final of that thing minus the initial. When we take the change, we look at where did it end minus where did it start, which means it can be negative, and that's okay. Sometimes we want that to be true. Other times, if it's negative, we know that we messed something up. All right. You should notice the last 2 bullet points on this page are copy-pasted, right? One of the nice things about chemistry is as we're getting through these definitions, you should notice, like, if I say one thing about one set of conditions, then all of the opposite things will also be true. So the first set here, when energy is absorbed by a system, then we say that that reaction or that process is endothermic. Endothermic. There we go. And Q has a positive sign. Q is positive because we're gaining heat, right? The system is absorbing heat. If you were to write heat in the reaction, it would be written as a reactant, right? Again, the opposites come into play here. So when heat is released by a system, the reaction or process is referred to as exothermic, and Q has a negative sign. Right? Heat will be written instead of a reactant. It will be a product because we're making it, we're releasing it, we're generating it into the surroundings. All right. Endothermic reactions are how instant ice packs work. Exothermic reactions are how instant hand warmers work. They're just opposite effects. It's a little pouch. Usually you have to like pop it. So it's a little pouch of water and some kind of powdered chemical. And we'll be doing something with that information and with those concepts on C-Day. All right. So make sure that you check on that. Also, so on C-Day in class, we'll be doing a lab. Fully remote students, I will have another video. It'll be up in the lab section. I will probably also put it here. I'm going to lump gases and thermochemistry into one topic, just so I don't have too many topics going on at once. Also on C-Day, you're going to do another thing on your own, and I'll be able to check in with everybody. I should be able to check in with people. I won't actually be able to check in with all of you. So if you have questions for the post C-Day stuff, right, we're doing a lab in class, but I want y'all to do page 53. Do these examples. They are using this equation here, right? This Q equals MC delta T. So we're using that equation to answer these questions, right? And what you'll notice is that question 1, question 2, and question 3 all have to do with water. The reason for that is right here. The specific heat for water, which is how much energy does it take to raise water's temperature by 1 degree, is on the reference table. So it's known information. So you'll be looking at that after C-Day, but before your quiz. So if you do have questions on this, Because I'm not going to be able to get everybody, I'm not going to get a chance to see everybody. If you have questions on this, you have to email me. Otherwise, again, I'm going to assume that everything is fine. I will make sure before the quiz on Friday, again, quiz is on Friday. Before the quiz on Friday, I will make sure to put up the solutions to this as a video. It'll go up in this little topic. In case you do have questions and you don't want to email me or you don't want to ask during class, there will be a video that goes up. All right, so this was like right before C-Day. We'll do a lab in class again on endothermic and exothermic things. This one is in your lab manual thing, so you'll be able to do that. And yeah, that's probably what we'll get through, because it's B-Day tomorrow, and then C-Day, C-Day. Oh no, I will get to see everybody. I will get to see everybody. Because Thursday will be group 1, Friday will be group 2. So I will get to see everybody. So I will get to go over this with y'all before the quiz on Friday. The quiz Friday will be due by like 7 p.m. Just to account for students that I have during the day. All right. If you have questions on anything so far, if you're confused on stuff, please send me an email. Otherwise, I'll see you in class. I'll see you in the next video. Take care. Be good, kids.